Okay, great. Get ready. In this lesson, we'll carry out a great Python exercise. We will learn how to calculate the efficient frontier of a group of portfolios composed of two assets, Procter & Gamble stock and the S&P 500 index. If you think getting there will be too complicated, don't worry. We will break down all the steps in an easy-to-understand way. The whole idea of portfolio efficiency will become much clearer to you. Are you excited? Perfect. Let's get started. The first thing we'll do is import the libraries and modules we typically use in our analyses. In addition, we will import matplotlib inline. This is a feature provided by IPython, available exclusively for the Jupyter Notebook. It facilitates plotting matplotlib graphs just below code cells and storing them in the notebook document. We'll be able to import this module by typing $matplotlib inline. The two assets of interest are P&G and the S&P 500, both stored in a list called assets. We will use data for the past few years, starting from year 2010. All right, done. We proceed with a few standard steps, normalizing to 100 and plotting the portfolio data on a graph to see how the two assets have been performing throughout the time of interest. Okay, so if we want to obtain an efficient frontier composed of these assets, we will need their log returns. Then, we will need their average and their covariance and correlation matrices. Okay, we can easily see P&G and the S&P 500 had a solid rate of return during the time frame we considered, and the returns are well correlated. Good. Now, we'll address portfolio optimization from a technical perspective. First, we must create a variable that will carry the number of assets in our portfolio. We will use it in our formulas, so they can respond to a change in the number of assets that compose the portfolio. It will equal the number of elements in the assets list. We can obtain this number with the help of the len function. In our case, we are talking about two assets, PG and S&P 500. Okay. Now, we must create two random weights, right? NumPy_random.random could generate two floats between 0 and 1. We run this code and we obtain two new values. Awesome! In the next cell, I combine the two values of this array to see their sum. You see, they don't add to 1. I hope you agree I must rerun these cells too many times if I want their sum to equal 1, right? Here is what we can do instead. In the first line, simply assign two random numbers between 0 and 1 to the new NumPy array called weights. The trick is to add a line of code that comes afterward. In the loops section, we introduced incrementing. Can you recall what it was? And do you remember the syntax plus equality could be used to designate we want the variable on the left side to be reassigned with the same variable, plus the value of the expression on the right side. The logic is identical with the distinction that the arithmetic operation is not summation, it is division. Weights will be defined as a variable equal to weights divided by the sum of these weights. Still hard to believe this will make the sum of the two randomly generated values equal to 1? Please don't forget, weights is an array. This means, with the second line of code, we turn the values of our array to W1 over W1 plus W2 and W2 over W1 plus W2, respectively. Well, when we sum these two, we will obtain W1 plus W2 over W1 plus W2, which equals 1. Let's see. Yes, absolutely. Therefore, remember this cell, specifically this line of code. It enables you to obtain two randomly generated weights whose sum will always equal 1. Great! I consider this lecture a preamble to the next one, which is the crux of this financial lesson, the Markowitz mean variance theory. See you in the next video.